go off when things don't feel right.
2.6 is on applications of rational equations. And of course, applications means word problems. So a little bit scary, but we can do this. So a few hints first of all with word problems. I'm not going to write a few of them down because you've heard them so many times. Read the question carefully, reread the question, draw pictures when possible, write down what you know. These are all good hints. But a couple hints that I'm going to write. One is let x represent the unknown amount and represent everything else in terms of x. So what I mean by that is try to avoid calling one unknown x and the other unknown, for example, y. If you could call one the unknown x and call the other one x plus 2, that would be the second one you're now representing in terms of x. Or the first one's x and the other one's 3 over x or something. Right? So try to use only x, x, x all through the whole thing. And the second one, write an equation relating the known and the unknown quantities. So there's some stuff you know, there's some stuff you don't know, and you're going to write an equation that relates the two. Okay, we've got three sort of problems that you need to know. The first one, it's not too bad. The other two are difficult. Okay, I'm just going to be honest about it. They're hard. So let's start with the first one here. An unknown number problem. So it says one natural number. Well, wait a minute. Let's stop right there. What's a natural number? Another name for a natural number is a counting number. And when you count, you don't start at 0. You start at 1. So the counting numbers or the natural numbers are 1, 2, 3, 4, ... One natural number is 4 more than another natural number. When the reciprocal of the greater number is subtracted from the reciprocal of the lesser number, the difference is 1 over 15. What are the two numbers? Wow, so we got a lot of stuff. What's unknown here? Well, what's unknown is the two numbers. So I said to always call the things x. So let's call the first number equals x. And the second number, what a lot of you probably want to write down is you want to put the second number equals y. But we're not doing that. Remember, we're going to write it in terms of x. So what do we know about the second number? Well, it says one natural number is 4 more than the other natural number. So if one number is x and the other one's 4 more, how much is the second one? X plus 4. No, you could also call the other one x minus 4, and then that would be the smaller number and x would be the biggest number. But the way I've written it, x is the smaller number and x plus 4 is the bigger number. Okay, now we're going to write an equation that relates these two things. When the reciprocal of the greater number, what's the greater number? Well, the greater number is x plus 4. What's the reciprocal of that? The reciprocal of that is 1 over x plus 4. So when the reciprocal of the greater one is subtracted from the reciprocal of the lesser number. So you have to be careful. You're not taking away from this one. You're taking this amount away from the reciprocal of this. What's the reciprocal of that? 1 over x. And when you do that, when you subtract this reciprocal from that reciprocal, the difference is 1 over 15. And this is the equation that you need to solve. Now, how are you going to solve this? Well, you're going to solve this the same way you've solved them in the last section. First of all, you factor the denominators. There's no factoring you can do. Second thing you do is you look for non-permissible values. Non-permissible value here is 0, so x cannot equal 0. Non-permissible value here is negative 4. Non-permissible value here, there is no non-permissible value. Okay, next thing you do is you're going to multiply everything by the lowest common denominator. What's the lowest common denominator? Well, we have an x plus 4, and we have a 15. So there's nothing in common. So what we have is we have an x, we have an x plus 4, an x plus 4, and we have a 15. And rather than putting the 15 here, I'll put the 15 up front, make it 15x. Okay, that's fine. Order doesn't matter when you multiply. So what you're going to do is you're going to multiply all these terms, all three of them, by 15x, x plus 4. 15x, x plus 4. 15x, x plus 4. Now I can do canceling. Here we have an x and an x. Can't cancel that x, right? Because that's a binomial. Remember, you can only cancel binomials with another the same binomial. So what we're left with is 15 times x plus 4 times 1. Well, multiplying by 1 will make no difference. Okay, here we have an x plus 4 and an x plus 4. Those are gone. So take away 15x times 1. Well, that makes no difference. Multiplying by 1. And this equals, there's 15 on the top, 15 on the bottom. 1 times x, which is still just x, and we're multiplying that by x plus 4. Good. Now we'll do some mountains here. So you get 15 times x is 15x. 15 times 4 is 60. Take away 15x equals mountains here. X times x is x squared. X times 4 is 4x. On the left-hand side, if we combine terms, we have 15x. Take away 15x. That just cancels. All you're left with is 60. 60 equals x squared plus 4x. Okay, we've got a quadratic. How do we solve them? To solve quadratics, we get it equal to 0 and we factor. So you either want to move the 60 over to the right or you want to move both of these things over to the left. Which one is way better to do? It's better to move the 60 over because we want to keep that x squared positive. So 0 equals x squared plus 4x. The 60 comes over and becomes negative 60. Now we factor. This is a simple trinomial. So what we're looking for is two numbers that multiply to 60, and there's lots of numbers that multiply to 60, so maybe I'll write them down. 5 and 12, 6 and 10, 7, 8, 9, 10. That's it. And they have to subtract to 4. Wouldn't you know it? The very last one. So the big number goes, first of all, x times x equals x squared. Big number is 10, small number is 6. Drag down the plus. Plus times a negative equals that negative. Great, we use the zero product property. So either this x plus 10 equals 0, or the x minus 6 equals 0, or both. To solve this one, we subtract 10 and subtract 10. So x equals negative 10. To subtract this one, we to solve this one, we add 6 and add 6. So x equals 6. Two answers? Well, there would be, and they both do work, except for one thing. In the question it said they were natural numbers, counting numbers, 1, 2, 3, 4. This is not a counting number. So it's not an extraneous root because it actually does solve the equation, right? It doesn't, I guess I should have checked for the MPVs, and it's not one of the MPVs, so that's fine. But we're not allowing it, we're rejecting it. And the reason we're rejecting it is because it's not a natural number. Not natural, I'll put. Not natural number. Alright, with this one, x equals 6, that's fine. It's not one of the NPVs, and it's a natural number, so it works. So this is one of your answers, x equals 6. But we want to know both numbers. How do I get the other number? Well, x is the first number, and x is 6. To get the second number, you do x plus 4, or 6 plus 4, so it's 10. So the two numbers are 6 and 10. Okay? Now we get to the hard stuff. Jenny can clean up the garage in 5 hours. When her son helps, they can clean up the garage in 3 hours. How long would it take Jenny's son to clean up the garage on his own? Alright, to solve these, you're going to make a little table. And what you're going to put in the table is you're going to put the people, the name of the people. You're going to put the time they take if they're alone. You're going to put the how much is done after 1 hour. After 1 hour. That's really bad, that alone there. And you're going to put the how much they personally did after completion, like after the whole job is done. Alright, so the people in this case are Jenny, and the other person is her son. The time it takes if alone. Jenny can clean up the garage in 5 hours, so if Jenny works by herself, it's 5 hours. When her son helps, they clean up the garage in 3 years. How long would it take Jenny's son to clean up the garage on his own? So this is the thing we don't know. We don't know how long it would take the son to do it on his own. So what should we call that? Well, we'll call it X, because that's the thing we don't know. After 1 hour. Okay, if Jenny takes 5 hours to do the whole job, how much has she done? Which fraction has she done after 1 hour? It takes 5 hours to do the whole thing. Then after 1 hour, she's done 1/5 of the job. If it took someone 2 hours, how much have they done after 1 hour? 1/2. If it took someone 3 hours, how much have they done after 1 hour? 1/3. If it took someone X hours, how much have they done after 1 hour? 1/x. Alright, after completion, like after the whole job is done, how much has Jenny done? Well, look, it took 3 hours for them to do it together, to do this job together. So if she did 1/5 in the first hour, then she'd do another 1/5 in the second hour, so she'd be up to 2/5, and after 3 hours she'd be up to 3/5. The way you can get that quickly is you take the 1/5 that we have right here and multiply it by the total amount. So times 3 equals 3/5. You do the same thing here, times 3, because that's the total length of time. If every hour the sun does 1 over x, after the 3 hours the sun's done 3 over x. Now we're ready to do our equation. If Jenny does 3/5 of the work, and her son does 3 over x amount of work, then together they do how much of the work? They do all the work. So it's going to be equal to the whole job. In other words, they do one job. They do the whole amount. I know this is confusing. It's always like this, where it's always going to be equaling to 1. It's always going to be 1 over, in this column it's going to be 1 over 5, or 1 over 3, or 1 over x. So there's a lot of similarity. What I recommend you do for the questions in section B and C is to look in your workbook, because there's other questions different from these ones, and you'll get to see just how similar they are to the ones that I'm doing here, and you'll probably pick up on the pattern and they won't seem so bad. But yeah, the first couple times you see these is quite challenging. Alright, what we're left with is a rational equation. That's the bad news. The good news is a pretty easy one to answer. So factor, we can't factor. MPVs, none here. There is one here. The x can't equal 0, and there's no MPV there. Lowest common denominator, denominator 5, denominator of x, and denominator of 1, because it's 1 over 1. So lowest common denominator is 5x. You're going to multiply everything by 5x. Each term, I mean, by 5x. And we cancel. The 5's cancel here, so you're left with x times 3, or 3x. The x's cancel here, so you're left with 5 times 3, or 15. Nothing cancels here. 5x times 1 equals 5x. Want to get our x's to the one side? Let's move the smaller ones. So take away 3x and take away 3x. 15 equals 2x. And you divide by 2 and divide by 2. X equals 7.5, 15 over 2, I'll put 7.5. 7.5 what? Well, we're talking about the time, 7.5 hours. If this kid, the son, Jenny's boy, works by himself, he'll take 7.5 hours to get the job done. If Jenny works by herself, she takes 5 hours. If they work together, it only takes 3 hours. Alright, so for these work problems, you'll set up a table like this. For these questions, the distance problems, you're also going to set up a table. Sadly, it's a different table. So you got 2 tables that you need to learn. So the object, in other words, what's moving? All these questions have stuff moving with the distance problem. Jerome rows his boat 24 kilometers downstream and back to where he began. So the object is actually the same thing. It's a boat, but there's two directions. There's where the boat is going downstream, so boat down, and then the boat's going upstream. They're going different speeds at those 2 places. The distance, he rows his boat 24 kilometers downstream, so that's the distance going downstream, and back to where he began. Well, he retraced his steps, so to speak, so it's another 24 back. Speed, when the average speed of the current, now, so a word about current, if you don't know what current is, here's my stream, and the water's going this way. This is the current, right? The water tends to go this way. If Jerome is in his boat and he's moving this direction, he's moving down here, that means he's going downstream. He's going with the current. But if he's going this direction, he's going up like this, that's upstream. He's fighting against the current. So let's look at when he's going downstream. What's his speed? Well, we don't know, but what we do know is that the current itself, the water, is moving at 2 kilometers an hour. So we don't know his speed going downstream. I'll just call it x. But however fast he's moving in the boat, he's getting an extra push. He's getting an extra push of 2 kilometers an hour, so it'd be x plus 2. Now, when he turns around and comes back up, he's still rowing. We're assuming he's still rowing or sailing, whatever it is, at the same speed. Like, he's exerting the same amount of force or whatever, so he's going the same speed in still water, so it's still x. But this time he's getting a push against him. He's going to be slower. So it's not going to be x anymore, it's going to be x minus 2. He's getting pushed against. So that's his speed there. Okay, for time. Now, to get the time, you need to remember something about time, distance, and speed. If you've taken physics before, you know this already. There's a relationship between distance, time, and speed. In order to do this, I'm going to make one of those magic triangles I'm sure you've seen in science. D is for distance, T is for time, S is for speed. So, for example, if I wanted to know what the formula is for distance, I cover up the D and I'm left with time times speed. If I want to know what the formula is for time, I put the heart here, it's distance divided by speed. If I want to know what the formula for speed is, I put the heart there, it's distance over time. So if I want to know what the formula is for time, put the heart here, it's distance divided by speed. Distance divided by speed. Oh, so if I want to know the time when the boat was going down, it's the distance, 24, divided by the speed, x plus 2. If I want to know the time here, it's the distance, 24, divided by the speed, x minus 2. Great. Now, do we know anything about the total time? Yes, the whole journey going downstream and back upstream is 9 hours. In other words, this, 24 over x plus 2, plus this, coming back upstream, the time that it takes to come back upstream, is equal to the total trip, which is 9 hours. That's what we have to solve. When we have that, we'll know how long, what his speed is in still water. That's what x is. X is speed in still water. So what I mean by that is, if there was no current at all, how fast would he be going? Now you're back to a question like last day, you just have to solve this. So the same thing we always do, we look for factoring, can't do it. You look for MPVs, and they are x can't equal -2 here and +2 there, so plus or minus 2. Lowest common denominator, you have denominators of x plus 2, x minus 2, and 1. This is over 1. So lowest common denominator is x plus 2, x minus 2. That's what you're going to multiply everything by. X plus 2, x minus 2. X plus 2, x minus 2, x plus 2, x minus 2. Ready to cancel? The x plus 2's cancel here. You're left with 24 times x minus 2. Plus the x minus 2's cancel here. You're left with 24 x plus 2. And nothing cancels here. You're left with 9 times x plus 2 times x minus 2. Yuck, got quite a bit to do here. So mountains here, 24x minus 48. Mountains here, 24x plus 48 equals, you can do this in any order you want. Probably most people will do mountain here. What I'm going to do is, oh, by the way, you don't do mountain, like multiply 9 times this and 9 times that, right? Multiply the first two and then multiply that answer by the third. Or the way I'm going to do it, I'm going to multiply the second two and then multiply that by the first. You can do multiplication in any order. So I'm going to do mountains and valleys here. So I have 9 times x is x squared. X times -2 is -2x. And positive 2 times x is positive 2x. So -2x, positive 2x. They just cancel. Great. And then positive 2 times -2 is -4. Okay, let's go back over here. We got a 24x and another 24x, so we got 48x. -48 and positive 48, those cancel. Mountains here, so it equals 9x squared minus 36. Better move it up here, I guess. This is a long question. It's a quadratic, so we want to get it equal to 0. Don't move them over to the left, because that would make your x squareds negative. So we're going to move it all to the right. So 0 will be left on the left. 9x squared minus 48x minus 36. Looks like Bobby Bridge, and it might be Bobby Bridge, but before we do Bobby Bridge, you should look for greatest common factors, and there is one. The greatest common factor is 3. So you get 3 times 3x squared minus 16x minus 12. Now, do you remember what I said about if you take out a greatest common factor and there's no variable in it, and it's equal to 0, you can just forget about the 3, right? Because I could divide both sides by 3, and then that would take care of the 3. Or you can think 3 times something equals 0. Well, the something must equal 0. So 0 is just equal to this. Should I rewrite that? All right. Since I'm showing every step, I will. Now, sadly, you do have Bobby Bridge, so you're looking for two numbers that multiply to 36 and subtract to 16. Could be 1 and 36, 2 and 18. Oh, I'm going to stop right there. There it is. They subtract to 16. So 0 equals 3x squared. Now we're going to decompose this negative 16, so it should be negative 18x plus 2x, and then take away 12. We pair them up. Aren't you loving it? It's such a long question. Greatest common factor is 3x, and you're left with x minus 6. Greatest common factor is 2, you're left with x minus 6, so it worked. 0 equals x minus 6 is in both of them, and then 3x plus 2, which means either x minus 6 equals 0 or 3x plus 2 equals 0. In this one, you'd add 6 to both sides, so you get x equals 6. In this one, you subtract 2 from both sides, so 3x equals negative 2, and then you divide by 3, and you get x equals negative 2 over 3. So what do you think about these answers? We're looking for the speed in still water. Unless you're the worst rower of all time, you're not rowing backwards. A negative answer really doesn't make much sense, so I'm going to reject this. It's not an extraneous root. It works, right? It's not one of the MPVs, which are positive, negative 2. No, we don't have a 2 or negative 2. The reason we're rejecting this is it doesn't make sense to be a negative number here. This is our answer. The speed is 6 kilometers an hour. If he wasn't in any current at all, then he would be moving at 6 kilometers an hour. Wow, that's quite a question. Okay, the last one is also a distance problem, so we need to write this same table down again. So there it is. So we've got Thomas in both cases, and in one case Thomas is running to school, and the other one Thomas is running from school, or home I'll put. The distance, average speed, walks home at an average speed. What's the average speed? Doesn't say what the distance is, so I'll call it x. Well, whatever the distance is to school is the same as the distance back home, so this is also x. What's his speed to school? 12. What's his speed from school? 4. The time, remember how we get time? Time is equal to, if you go back up here, if you cover up time, it's distance divided by speed. So distance of x divided by speed of 12, distance x divided by speed 4. Okay, now we want the average speed. Well, to get the average speed, let's look back up here. If I'm looking for speed, if I cover up the speed, is distance divided by time. So if I want average speed, I would take the total distance and divide it by the total time. So what's the total distance? Well, to go to school is x, and then to come back home from school is also x, so the total distance is x plus x. The total time to go to school, it's x over 12, and to come back from school, it's x plus 4, or x over 4, so we add those together. If we can solve that, then we can answer this question. Okay, we can solve that. The top is very easy, isn't it? X plus x is 2x, so we have 2x over x over 12 plus x over 4. Well, why don't we just take this bottom part here and just solve that. We'll just figure out what that equals, and then we'll do the division here. So maybe what I'll do is I'll rewrite that over here. So I get x over 12 plus x over 4. This is an expression now, it's not an equation, so be careful here. What your steps would be to look for the non-permissible values. There are none. It would be to look for a lowest common denominator, which is 12. Then what you would do is you wouldn't multiply everything by 12. That's what you do when it's an equation to get rid of the fractions. If it's an expression, remember what you want to do is get the lowest common denominator in both of these. You want this to be something over 12 plus something over 12. You want to get common denominators. This one already has 12, so it's still x. This one, the 4, what do you have to do to 4 to get the 12? You have to multiply by 3, so we do the same thing here. And you end up with 3x. Now we can add these together. When you add fractions, you just keep the denominator the same. Add x and 3x, which gives you 4x. Hey, look, you could actually put this in simpler terms here, because there's 4 on the top, 12 on the bottom. You could divide them both by 4. 4 divided by 4 is 1, so you just get x on top. 12 divided by 4 is 3, so x over 3. So what our question becomes is 2x over x over 3. So what you're doing is you're taking 2x and you're dividing it by, that's what that sign means, dividing by x over 3. And let's give this a denominator. You can make it 2x over 1. Okay, so I don't know, this is just getting so messy. So how do we divide fractions? You keep the first one the same and you multiply the reciprocal. Flip this one, so 3 over x. Let's do ninja slicing here. You got an x on the top, you got an x on the bottom. Hey, That worked out very nice. All we have left is 2 times 3 is 6 over 1. You don't need to put it over 1, so our answer is 6. The average speed in the entire trip is 6 kilometers per hour. Alright, I imagine you feel a little overwhelmed by all that. I know it's difficult. I'll say it again. I think if you look at the questions in the book, there's other questions similar to these ones, but are different. And I think if you look at those ones, you'll see that they're all quite similar to each other. So good luck, and don't get frustrated.